This is a very, I think, a very important topic, and ever since I was active in the field, I feel like something needs to happen there, and getting like um, the science and the politics a little bit more effectively working together. Um, I'm sorry I can't stay for the entire time of the meeting. We have some family issues going on. I spare you the details, but I regret that very much. So please feel free to be in touch afterwards. I want to start with a simple question. That is, when was the last time that you tested the quality of your water at home? If you would go out there with that kind of question in the public and would ask people on the street, most likely 99% of the people would say they never did. And I think it's fair enough that we, at least in many countries, don't need to check our water quality all the time. It's very well there's very good surveillance going on. They monitor it, and we feel safe about it. And then I think it would be fantastic if we would have the same kind of thing for our air, our environment, especially with respect to like the spreading of dangerous and infectious disease. So with this in our mind and with the experience during the pandemics, we would think we are addressing the question that to a big extent was triggered to Aisti's work in Lithuania when we met up, is why not like through finding a strategy that you actually test the environment, so make the environment safe so that people are safe. So kind of a non-invasive way of testing. So this is a collaboration with Yanir, between Germany, if you want, between Germany, the US, and Lithuania. Um, so the idea is, in a nutshell, to be simple and silent. I say very often that means we test the environment, not the people. We try to be non-invasive in that sense. We try to be not. We try to be anonymous. So it's more so you basically maintain the entire privacy issues. You don't have any issues along those lines. It has a very low societal burden because you don't need the people. I will introduce a few ideas. I guess Aistis will tell you more about them too, for some of them. And technologically, it was important for us in our study. We started this little pilot to also have the same kind of workflow, the same kind of workflow in the lab going on with the different environmental testings. And the goal by the end of the day was to have an early detection without keeping the environment safe, without having to include the population itself. There are three layers we came up with. That's the first one is the sewage water testing. This is pretty good on large scales in early detection, as you will see, and but it's poor in localization, right? You don't really know where it comes from what household. You don't even know the street where the virus came from. So its localization is not very good, but it's easy, quick, and on a large scale, meaning you can test an entire city very easily that way. The second thing is in surface testing. You go significantly down in scale. So you test, let's say, a building or the rooms in a building. This is where Istis is the expert. I would call it now the intermediate scale. It's much better localized. You really know, if you find a virus on a door handle, this must have been people that, use this door handle. Its timing, in terms of timing, is not as good, because the virus just stays there for quite some time. The person may have long gone, and the virus is still there. So the localization in space is good. The localization in time is not good, I would say, as a physicist. And last but not least, what we have there is what we call air testing. So you actually try to look for the virus in air. So you acquire some sample from the air. This is, of course, it is spatially and timely correlated. The person really needs to be in that room in order to find the virus in that room at that time. The shortcoming is it is technologically a little bit more work, so it requires more instrumental systems, and it's time. It takes time, so you need to collect air samples for about 1 or 2 hours. Maybe in the future this is going to be a little bit improved, but right now this is a limitation. Certainly, it doesn't go very quick. So, but by combining these three things, you think you have a very few powerful things at your hand. So here's something, because I want to keep this quick, something from the work of the Drewes group in Munich. This is one of the famous sewage water groups in Germany. It was very active also during the last pandemics, where you see in blue, you see the virus load in the sewage water, and in red, you see the actual survey from the actual surveillance from our from our public health institutions where people are tested. And you see that the sewage water is a little bit ahead of the curve. So you get an early warning when you test the sewage water of what is going on in your district or in your larger environment street. Maybe larger companies even could have that, but you need some certain amount, because usually stool is a much better indicator than urine is. So people need to spend a significant time of the day wherever you're going to test. We did the same thing in Dortmund and in Bavaria, together with some collaborations in Germany. And I can tell you, we came up with very similar results. So this is really very straightforward. It's easy to require the sample, and it's easy to test. Surface testing, well, I keep very short because the expert is there. We learned everything I know from Aistis and his colleagues. So we have basically what you can say. Long story short, what you can say, you swap door handles. So again, the accumulation of the sample is quite simple. You can pool, you can do all those kind of things, and then you can narrow it down to a room, to a corridor in a hospital or in a school, and you could say, okay, there was somebody that had virus on his hands or her hands. And then now you can think about what kind of measures you need to go through in order to stop it. And last but not least, we did some air testing also. Basically, we had a person we knew that in an office sitting, he was actually infected. And what we did, we tested the person directly and the air, and were able to correlate the data in some sense. So what I can tell you from our experience is what you can use air samples for is that if you have an office, maybe public transportation, an airplane, and kind of things like that, I think you could test very efficiently in there, and you can say, was there virus in the air? So did it really come from people and not just staying there since a while? And then you can say, was there or was not there? What is really tricky is to say, was this a highly infectious person or not very infectious person? This is hard to say. It's more an all or none, kind of yes or no kind of answer. But what I can tell you, if you do collect for approximately 2 hours, we had barely any false negatives. So as soon as there was a person with a CT, let's say below 30, so measured CT, PCR CT value of below 30, 25, 28 or something in the room, the air also was infected, measurable. So it is definitely a way to measure infections in small rooms. So now we are an even lower scale, but you need an instrument to collect an air sample, which is somewhat tricky. I want to summarize the ideas. So you test the environment, you make the environment safe to keep the people safe. You can go test the building, the surfaces when people are even there. You can test the air. You can have it basically incorporated in the ventilation system, and people wouldn't even realize that it's there. And you can test sewage without even being in contact with anybody. So it's something like an testing that, just like your water is tested and monitored so that your drinking water is safe, it could be some kind of a testing system that runs in the background. And now you can think about the combinatorics of those three things. So only if the surface is positive and the sewage water is positive or something like that, then this triggers an alert for more like personalized testing, for instance, or for some kind of a safety measure that you have to think of. That depends, of course, what type of virus we are talking about. A couple of improvements I want to very briefly mention, and then I'm done. is air monitoring may be easily integrated in ventilation systems. So this is something that we could think of that would make everything a lot easier to already incorporate it in like in airplanes and buses or in taxis and cars. Surface sampling could be basically performed by robots or by just submitting a napkin from each office in a building or something like that. And simpler on-site detection system, meaning like instead of using PCR, you use modern spectroscopy tools or something like that, so that you can easily and quicker on-site maybe test whether something is positive or not. So I think there's a lot of potential in that. It already works to some extent, but I think it can be rolled out big time so that we can actually have a safe environment, just like we have pure, well-monitored water. Thank you very much.
Matthias, we hear from business and then we move into what can be implemented from this, exactly what you have spoken about, and how we are planning to implement it in India.
Okay, let me share. Great presentation, Matthias. Hopefully I'll respond to your latest email. But with this presentation to some extent too. Great. So can everybody see my slides? Just checking.
Yes.
Yeah, perfect. Okay, so Matthias already started about this environmental testing ideas, and I will sort of double down on more like a specific use case in daycare. I immediately acknowledge that this is not just my work. Also, Kristina Daniūnaitė, Professor Dovilė from Santaros Clinics and Vilnius Municipality Public Health Bureau are like sources of this information and data too. So essentially, the situation in summer of 2021, this is after essentially a big wave in 2020 and winter 2021. There are several learnings that we had in managing the pandemic. One is that mass surveillance testing proved extremely valuable in 2020, where you essentially just, if you get like one COVID case in an institution, you test everybody and remove all the individuals that are positive, has saved a lot of lives, especially where the lives were at risk, like hospices and this type of high-risk institutions. However, there was already a public anxiety about mass testing and having to test people with invasive methods. So there is like public resistance was developing, and sort of approaching autumn 2021, and school opening was scary for all of us who kind of lived through 2020. So there needed to be some control in schools and nurseries as transmissions hub, but the invasive testing of children was not something society was willing to accept. We actually did do some pooled PCR testing for higher grade for older students, but definitely not for kids. But yeah, nobody was going to close schools in 2021. So we were sort of thinking, okay, what do we do? How we still control the pandemic to some extent? And then actually in January 2021, Kristina at the Vilnius Life Sciences Center, they did some experiments with swab collection from surfaces that Matthias already talked about. So essentially doing a pooled PCR swabs of door handles, keyboards, surfaces where people sit and kind of basically exhale a lot of aerosol. So this would be keyboards, desks, door handles, and essentially this was done like for fun, but it actually yielded very, very good results. Anyway, you get like a high, what we classified as high PCR, high concentration PCR, you'd essentially pick up infected persons quite quickly. So that proved to be which triggered the whole idea of, okay, how can we scale this? Can this be adopted to wider public use? And then from this one trial in Life Sciences Center, we've essentially precisely identified where infected persons sit, and the tests were confirmed by PCR. We ran further pilots in hospitals, which proved to be much less successful because of the high degrees of disinfection. So in hospitals, several times per day, people swab all the surfaces, and if disinfection works well, then suddenly this method stops working. We did identify some hospitals which were not very good with disinfection, though, as a side effect of these pilots. But that's an important consideration. This is where air still works, but surfaces stops working. And then we also tested some public government institutions like the results of, for example, swabbing the parliament were not released in the end, but we did have these things as like a good experiments. It actually works very well. And then, so this was the idea. Okay, why don't we actually enroll this as part of a big people coming back to schools in autumn 2021? And we ran the extensive program, essentially all the daycares in Vilnius, which is the capital city of Lithuania. So we have 70 participating institutions. There were sort of at the beginning of the week sweeps of classrooms, essentially just to identify whether like a virus is in classroom or not. So we would swab 5-6 different places in various places where people where children touch, and we just pull all the samples together into one. So you basically perform one test per classroom, and then what happens if the test comes back positive as high concentration of virus? Next in the evening or next morning, parents and teachers are informed that high levels of COVID were detected in their classroom, and then they could go for optional PCR screening of children, parents, teachers, and cohabitants. So there was no forced indication, but they could go to test, and people were quite willing to do it. And these are some of the okay. But before I go to results, I think it was very effective in two ways. One, it would identify when there was somebody infected in the classroom. I don't think we had many cases where the PCR would come back zero to everybody. So it's definitely when it is positive, it did flag. But the more interesting effect that we saw is the moment that parents get notification that there is a high degree of virus, they don't send their children to daycare next day. So it's even like a behavioral change, which epidemiologically is very sound. It's nothing to do with testing per se. So you would get essentially after this notification goes out, nobody sends their kids to daycare for a couple of days, and that then you can not even test anymore. It's just it already stops transmission quite effectively. It did wear off as there were more and more alerts, but at the beginning the effect was very good. And here is some data. So this is from about 70 daycares from 2022. So this is from January to essentially end of April. So we can zoom in into like one specific line, but for example, this is end of January, beginning of February, 68 daycares tested, total about 4,000 samples collected from 700 classrooms. There was 133 classrooms flagged as high concentration of virus, 90 as medium, and about 500 as none. As a result, next day, about 300 people got tested, and 100 came out positive, PCR positive, 66 children, and 32 parents and teachers. So this is essentially a sort of very, obviously a week at the height of a pandemic, but still you get like a very high degrees of positivity, sort of 25%, 10 to 25% every time we would run this. So I mean, this is not like a scientific. We didn't run scientific data collection. Unfortunately, this was done by sort of aggregate numbers. But in effect, this would remove a significant number of infected people from classrooms. In addition to the social epidemiological effect that I mentioned of people not sending people to children to class next day. Actually, personally, in my daughter's daycare, the high concentration alert was triggered twice, and once it was a music teacher, and second time it was the class teacher that were positive, with no children reported positive afterwards. So again, sort of a very practical implementation of what Matthias described happened before the kind of a structured approach, but was very well accepted by society. And because it's not invasive, everything is optional, people can make their own choices, they're informed. And just some conclusions. So one is, infecting people deposit virus on surfaces, and it can easily detected using PCR swabs. This is somewhat, there were like skeptics when we started this, and there's the scientists and experts talking about virus doesn't survive on, like, basically all of this is obviously nonsense. It's extremely well detected once somebody is actually breathing it out. And surface swabbing and pooling is a very cheap space to test large spaces. Again, kind of same conclusion as Matthias mentioned. You can cover and do a very good localization in space. And another thing I wanted to mention as well is there are epidemiological impacts beyond isolation of infected, which is basically informing people there is somebody infected, makes them less likely to go there. It's not rocket science, but I mean, it is important. And the public acceptance is super easy. This kind of stuff, nobody cares. Swab as much, even the anti-vax people, anti-testing, everybody would be like fine with that. It's like you can still ignore it, and that's fine. But people who don't want to ignore it cannot ignore it. We did some other, and then as a localization in time problem, I've also reiterated it's unclear how long traces can be spread detected after the infection. It's if you completely disinfect surfaces, it's still, we haven't tested of like if somebody recovered from infection, how long do they still, can they still deposit traces of RNA? I don't know that. So that localization in time is for sure problematic. We kind of extended this idea into several directions. Matthias went with air testing. We also did some testing of things like masks. That seemed like a natural way of disposed mask testing for medics as another way to identify. We had some problems collecting swabs, but essentially this idea for institutions like hospitals where everybody wears masks anyway, something like this also could be explored as indirect testing, where you dispose your mask into a specific bag and you can run tests on that. So this is something we experiment with, but I mean, got less, didn't have like a bulk testing. So this is something I would recommend, let's say, clothing / masking, because if you do deposit virus on surfaces you sit at and are near, naturally you would dispose it over your clothes. And I mean, this should be detectable in any sort of peripheral areas which you wear every day. So things like testing clothes, masks, etc. There are like a lot of yeah, but for non-disposables it becomes tricky. So yeah, this is kind of what we did in 2021, 2022. It was very cheap, was very effective, got good public acceptance, but there are I'm very much supportive of an idea of having some combinatorial things. But if pandemic started again, and I was again in the same position trying to manage it, this is where I would start. Because essentially at the beginning of the wave and identifying early spread when there was no spread before, this would give you a very timely indicator. Once you pass the peak and there is like mass infections, it becomes much less effective. So yeah, this is my quick use case. Thanks.
Thanks, Estes. I will extend to what Matthias and Estes has already talked about, and maybe extend the argument to tuberculosis in India. Before I talk about what we are planning to do with what knowledge has been generated by Estes and Matthias, I would like you to have an understanding of tuberculosis in India. I just want you to gather some idea about tuberculosis in India. How does it actually pan out in India? So we start with the last few days we have had a chance of listening to everybody, and to be very honest, I'm taking the knowledge that we have gathered for last 4 or 5 days on non-politics group, and because it's a diverse group, I think the people who are gathered here need to have an understanding of how tuberculosis is in India. So the last time India could think of controlling tuberculosis or eliminating tuberculosis was the early 1960s. So 1962-63 was the last time India thought that they will be able to eliminate tuberculosis, because the focus, the primary area of focus in our approach to tuberculosis in 1960s was in the community. So we identified districts as the center area of intervention as far as tuberculosis was concerned, and taking to the families, going to the community. We thought we would be able to control tuberculosis. And we would have been successful, but for the fact that the things around us across the world changed, and they wanted us to change our strategies as well. From the introduction of X-rays, the mass miniature radiography that came up in the early 70s, to the fact that people told us that, look, you are poor. Why I'm saying this, because again, Joe was talking about equity and other things. They told us that India and other parts of the world are poor. They don't have the resources to take care of their programs, so they need to use an approach which is devised by us for them. And this came in the form of a paper which was written in 1979 by Welsh and Warner, which was published in NEGM. This is an editorial that I have very recently written about. So this shifted the goal from a whole approach, a wholesome approach, wherein community was the focus of tuberculosis management, to selective programmatic healthcare, program-based healthcare, the failure of which we have already seen, that we are not able to take care of it. And despite the amount of time, money, and resources that we are spending on tuberculosis, we have not been able to take care of. So that's the basic context that we have with it as far as TB is concerned. Again, this is something that I have already talked about, that despite having a program in place which talks about different strategies, using multi-layered approaches, wherein we start with investigations, we start with picking up patients who are at the higher risk, to contact tracing, to short course chemotherapy, everything is being done, but yet we are not able to take care of tuberculosis. The goal for 2025 was, for example, the goal for 2025 in India was to maybe achieve a 10% reduction in notification, but we were only able to achieve a 2% reduction in notification. So we are not nowhere near elimination that we thought we would be achieving in 2025, or the goal that has been set for us by the WHO of achieving elimination by 2030, or although that the objectives or the measurements for that elimination are not very scientific, but still our chances of reaching this as a whole, the whole world, the chances of the whole world to reach that goal of elimination by 2030 is very limited. We will continue to have TB with us, unfortunately, for a longer period of time, because the focus is again on identifying high risk, making a management of high risk, and then not taking care of the community as we used to do earlier on when we started. So this is something that we have already talked about, program-based approach, the failures of program-based approach. So what's the solution? So when we met for the first time in Unpolitics meeting, we wanted to find a solution, and me and Yanir had a talk about it. We said that we are failing, we are not able to take care of it. We need to find something which is more easily implementable, and is able to take care of the fact that we don't have to go to individuals. The problem with going to individuals was, one, that TB in India is associated with a huge amount of stigma. So if you have 25% of your TB patients coming from a country like India, and being associated with such amount of stigma, the chance that a patient of tuberculosis coming forward and getting himself tested through healthcare system on his own is very limited. Even if you go to them, approach them on a daily basis, the chances are not huge. We, as I shown in my papers, we went door to door, still were not able to take hold of the patients which were supposed to, based on the data that we had available with us. So we wanted to probably shift the burden of diagnosis from individuals to the community. Again, something that which we saw working in the 1960s, wherein we were shifting the elimination strategy to population and not to the individuals. The problem was that the technology that we thought of was costly for us. So the average cost of the machines or the technology that we plan to use in India for this purpose was in excess of $100 for us in India. The cheapest of it was $1,000 for us. So that $1,000 was too huge for us to roll out on a community basis and do the investigations on a routine basis. So me, Matthias, and Yanir sat down, and we thought of a solution which was more implementable, was more cost effective in terms of being rolled out in a larger population. And we talked about a technology which was locally developed. It was a low-cost air sampler designed for environmental surveillance of airborne MTB. Matthias and Astius had largely worked on the viral side of it. They had not tested the bacterial side. So we were actually looking at the bacterial side for the first time. Eventually, the methodology, the strategy would have stayed the same, but nevertheless, they had not tested the bacteria. We were trying to do it with the bacteria. The technology was simple. It was a 12-volt fan, or we plan to have an integrated unit with a rechargeable power supply. Both of these have been developed by now. A kitchen funnel, a PTFE membrane filter with a pore size of this and this. This is something that we initially thought about, that this is how we will make it, because it was supposed to bring the cost of the unit to less than $10 to $15. So that was our aim. So we wanted to reduce the cost drastically so that it could be implemented at a larger scale. The idea was that it has to operate continuously for 1 to 8 hours, variable. We talk about that bit in detail. Passively concentrating airborne aerosol particles onto the filter membrane, which both Astius and Matthias have talked in detail how this works, and which is subsequently processed in lab using PCR. Again, need to bring in the context here. We initially thought that the district that I work in, the district wherein my medical school is located, one of the blocks of that district will be taken as a rollout strategy block, and we will start doing it over there only. The rough population of my district, of the district wherein I work, is around 1.5 million, and we thought that we will be working around with a population of 100,000. So 100,000 was the target population. We needed some money. I thought why don't we go to the government? But that was not the only problem. Money was something which we could have managed. But I also wanted it to be integrated with the existing strategies that are in place as far as tuberculosis is concerned. So I went to the government. I told them, this is something that I have in mind. So how do you see it, whether we should be rolling out it or not? So they were happy that there is something that is in place. And they offered me that instead of going for a block, let's go for a district, a larger population district. Not the district wherein I work, which is, as I said, 1.5 million, but a smaller district with a population of around 400,000 people. So we'll go there, start working there. When I submitted the proposal to the authorities of that district, they were happy to fund me the required money, and that's how we started rolling out. So we built the basic apparatus of thinking that we will be rolling it out in that particular district. So, but what eventually happened was that the same authorities took it to the Department of Health Research in the Government of India, and they said that instead of focusing on one single district, let's go to 2 districts now. So we don't take care of one single district, we take of two districts, and within those districts, we will pick up the urban-rural variation as well. Now, the district that initially was allotted to me was primarily urban in nature. So they said, you take your own district, take this urban district as well, and we pick up these two districts and start intervention in these 2 districts as far as this project was concerned. So what we have done till now, as far as this project rollout is concerned, that we have already tested the benchtop feasibility. We have developed the apparatus. We have developed the technology. We have developed the sampler, air sampler. We have already tested its feasibility, and the initial lab experiments have demonstrated the physical capacity of the device to trap aerosolized particles with the target size. So we were able to pick up these particles. So airflow rates and filter loading efficiency have been characterized at different sampling durations. So we have seen what works at 1 hour, we have seen what works at 2 hours, we have seen what works at 3 hours, and we have been able to rather assign different time zones as far as this project is concerned. Regulatory and ethical preparedness has already been taken care of. We already got the ethical clearance for that. And based on that ethical clearance and the approach, this is the sample matrix that we are trying to target in next 6 months as far as testing this air sampler is concerned. So we are testing 10 high-risk community settings across 2 districts. So 2.4 million is the population that we are trying to test. As both Matthias Estes have said, that we need to identify areas wherein we will put these air samplers. We can't go into an open domain and start putting it in general public. We need to be focusing on certain areas or certain locations wherein we will be putting these apparatus. So we plan that we will have prisons and correctional homes was one place wherein we thought we will be using. You'll be surprised again, putting it into the context, one of the jails that we have, one of the prisons that we have in my district, when we did that X-ray investigation on them, and we thought we will take it to them, we were surprised that around 60% of those patients with those who are in these jails had an altered chest X-ray. So jails and prisons are one of the areas wherein we are thinking of using these air samplers. Hospital inpatient wards. Now, initially we thought that we will go to the respiratory medicine department and start putting the air samplers there. But when I went to my respiratory medicine colleague, he said that my ward may not be the ideal place to test this, because they use HEPA filters within their wards, and the respiratory medicine wards are much better ventilated as compared to other wards. So maybe medicine ward is somewhere wherein we will be putting these air samplers. Hospital outpatients. So we identified within the hospital the worst place, or the place wherein our chances of picking up tuberculosis at the highest level is the radiodiagnosis department. One, because almost the entire radiodiagnosis is centralized, as far as its air conditioning is concerned. There are no open windows and doors there. It is usually housed in the basement. There's a huge amount of people that are there who are getting investigated. The stay time of each patient who is there in the hospitals, in the radiodiagnosis departments, is much higher as compared to other departments. Somebody undergoing a CT, an MRI, or an ultrasound, they have a higher time to spend within that hospital, within that particular zone, the radiodiagnosis. So we thought that we will pick up radiodiagnosis department. We'll go to the government schools, again, secondary and senior schools, preferably schools with a larger population, not the smaller ones. So we will go to the schools where a substantial number of students study. And then there are prayer halls, whether it's the temples, the mosques, or the gurdwaras, particularly on days wherein there is a gathering as far as these places are concerned. So a temple which is watching a gathering, or a mosque or a gurdwara which is watching a gathering, so we will put our air samplers there. We plan that we will do this across both the districts, and the number of sites per category is 2. The total sites that we are trying to identify is 20 sites, and we are planning to collect 50 samples per site. So in all, we are targeting 1,000 samples over a period of time. And these 1,000 samples we are planning to get investigated through already identified RT-PCR machines that are there in our district and the adjoining district that I talked about. At the current point in time, my district has around 40 amplification machines, the TrueNat and the CBNat machine. So we rolled out across 15 blocks. So 15 blocks have roughly 42 CBNat, TrueNat machines. So roughly each block has 2 to 3 CBNat, TrueNat machines, and these will be ones which will be provided by the government as far as this testing is concerned. So this is the matrix with which we have gone to the government, and we are expecting some response from them. If we get the funding, we will roll it out in both the districts in the next 6 months. If we don't get the funding to the level, we already have the funding for one district, so we will straight away start with one district. But as I said, my intention is that instead of taking it as a project at this point in time and asking the government to later integrate it with the program that is already in existence in the country, I want it to be integrated with the program from the beginning, because then it makes it much more easier as far as implementation is concerned. So hope that we get that. And if we don't get that, we still have a chance of being able to prove that we were successful in terms of rolling out this air sampler. Thank you so much. If there are any questions on this, or if there are any questions to Estes or Matthias, we are more than happy to talk about it. Thank you.
So Thank you, Sunil. Thank you, Aestis. And I think Matthias did have to go and take care of his family. Let's take questions. And does anyone want to ask a question? And maybe, Aestis, you have a question for Sunil, or if someone has a question, please go ahead.
Well, I'll just start with a comment that this is excellent. I think really looking forward to the results, because if this works structurally, this could be like a very outsized impact. So really great idea.
Yeah, let me share. There is a small paper that has a picture of the device, the original concept. And I should be able to find it in a moment. But in the meantime, please go ahead, Basir. Yeah.
Greetings. I have survived multiple respiratory illnesses, and they were some of them were actually weapons grade, because the infection took place in military related activities, and was lucky enough to survive them. And if you look at the chat, you will see the history 2018, 2019. I very much encourage. So as a result, I developed a superpower of paying extra attention if there's a very weird, awkward coughing. And so Mike and Sunil mentioned that, and I proposed the idea. I thought of the idea of using. I've heard of applications of AI. I'm in a busy place. Sorry about that. AI voice analysis, sound analysis, and Sunil mentioned that they're working on it. So I'm very eager to learn more about it. Thank you.
Thanks, Basir, and I would inform you on two accounts. One is something that we are trying, and in fact, we have completed a project already on that, wherein we recruited around 250 patients who came to our respiratory medicine department with all types of cough. So we didn't begin by identifying tuberculosis only. So we admitted or identified anybody who was coming up with cough to our place, whether that was influenza, COVID, or tuberculosis, we didn't know, or even chronic bronchitis, we didn't know. So what we did was that we took the samples from all of these using an application, AI application, which was loaded on our telephones, which were developed by somebody. We can talk about the company later on. So it was developed by the technology, them. And what we did was that eventually we developed we segregated them into two arms. One was the arm which turned out to be TB positive later on through our CBNAT or RT-PCR, whatever you want to call it, CBNAT, TrueNAT, or RT-PCR. And the second arm which was neither TrueNAT, CBNAT, or RT-PCR positive, or were healthy volunteers. So we eventually had two arms. One was healthy volunteers and non-TB patients, and second was the arm which was TB positive. And we were surprised that our signature cough AI was able to pick up around 95 to 97% of TB positive patients. So all in all, it was a good sample. Over a period of time, I talked with those who had developed the application, and they diversified into different types of coughs. And they said that they will be able to eventually develop a signature for each type of cough. So it's a chronic bronchitis cough, this is the signature for that. It's an influenza cough, it's a signature for that. Last week, we had a meeting with the CDSCO. CDSCO is the central agency that looks about the clinical trials in India and approves a product for marketing in India. So we had a meeting with them as well, and the company that developed the AI, and because we tested the AI in India, so we are trying to roll it out in India through that company, of course. So that will be rolled out as an application on telephones, on mobile phones across India. That's one which we did. Another company in India is already working on it. Again, they are at a much slower pace than what we did, and that has been demonstrated as a concept paper last AI conference that we had in India. So it was demonstrated as a concept proof of concept paper to them, but they have not tested it at the level that we already have. So there are more than one player who are looking at AI as a tool to pick up different types of cough, COVID, influenza, and chronic bronchitis or tuberculosis. And eventually, I think over a period of time, we should have this in place. But I have a word of caution on this, because we are eventually trying to roll it out in populations wherein our health and wellness centers sit. So our health and wellness centers are manned by people who are trained nurse practitioners. They man these health and wellness centers. So we are trying to roll them out in our own health and wellness centers. We have roughly 250,000 health and wellness centers in the country. So we're trying to eventually roll it out in some of these health and wellness centers and see how they work. The only problem is that these tools will eventually function as screening tools. They won't function as diagnostic tools or an intervention tool in terms of being able to initiate treatment. So we'll still need to wait that we start treatment on the basis of these tools, and they will continue to be something which will be able to serve as screening tools for individuals only. So you have a cough, you want to see whether it is tuberculosis or something else. It's a fine tool to have. Then you can go to the healthcare professional and see, look, get me investigated, see what it is.
Thank you very much.
My follow-on question is that if we do air sampling and we detect positive, then we still have to identify who has it. So the cough testing could be used to reduce the number of tests that have to be made afterwards.
So the idea is to integrate the two. The idea is to reduce the burden of shifting the proof of diagnosis to the individual, probably to reduce the stigma. That's the idea. But of the two, if you ask me which one should be the one which we should follow as a public health strategy, I would still go with air sampling. Air sampling to me is the answer to all of the problems. So you take care of a lot of things if you are taking care of the air sampling. You are telling the individual that, look, this is not because of you. At this point in time, if you are tuberculosis positive in India, you are eventually taking the risk of blaming that individual with something wrong. That this is his fault. This is not the fault of the system. This is not the fault of the air that he's breathing. I told you previously as well. We followed these 100 patients, which was as I was responding to Basir. We followed these 100 patients. It was a cohort of 100 patients. You will be surprised that out of these 100 patients, 20 were such patients who had a repeat infection within a period of 2 years. Of all my patients for last year, we followed a group of around 2,800 patients who were diagnosed with tuberculosis. 2,800 is huge number. You'll be surprised a substantial number of those, around 15 to 18% of these patients reported of being identified as TB positive within a period of 2 years. So they were put on treatment. The treatment was completed, and once a treatment is completed, they are sent back home. So within a period of 2 years, they will eventually come to us again. And the problem is that if he comes to us within a period of 2 years, there's a higher chance of the disease being multi-drug resistant, extreme drug resistance tuberculosis, and the fatality of the death because of that is going to be higher than because of normal tuberculosis. So if you ask me, what do we need to change? We need to change the air around, integrate it with, as Matthias said, integrate it with the ventilation system, improve the ventilation system based on what we identify through our air sampler. We have a higher chance of being able to reduce TB burden across the country.
Thanks, Sunil. Other people, if they have questions, please raise hand in one way or another, or come on. Aestis, I have a question for you, and I would like to hear from you about the process that you used in buildings where you did detect localized efforts. Just give us some sense of the dynamics of how it worked.
So there are several categories. So for public institutions, like government institutions and hospitals, this was very straightforward. So in whoever's office it was detected, they would be tested, and usually like very few people would actually object. And then there was no isolation prior, but they would just go test in the evening, and if they're positive, they then like self-isolate. Then for institutions that are like daycares and schools, everything was optional, so voluntary. People would be informed, and they could test, or there was no like restriction to further actions from there. So there were two approaches really. I think it's not like mandating anything in at scale for all the people is something that would have had no acceptance. But usually we stopped doing contact tracing like in mid 2020s. Like that's basically fake. I mean, unless you really control everything and you're chasing one case, it's more we're big fans of just testing more. Yeah.
No. Other questions? Go ahead, Joe.
Yeah, I just was really excited to hear about all of this in the context of our pandemic plan. We have this idea that we can create green zones, areas where there has been elimination, and that's going to require very good surveillance to ensure that new cases are caught early and therefore uh, lines of transmission are shut down early. And I think this is more of a comment than a question. I think this is just in the context of that, viewing it from my perspective, this is really important work that will help to ensure that our pandemic plan is a success when it's published and when it's implemented.
Thank you. Naomi.
What's striking me about these presentations is, I mean, they're taking place literally all over the world, and the issue of what's known in the medical world, to my knowledge, as kind of compliance and the stigma issue is so important. And it manifests differently in each community. So Sunil is saying that in India, there's huge stigma to being associated with having TB, and that somehow it's your fault or whatever it is. There's a huge stigma, and Astis was talking about being able to, you can't require anything. You need the buy-in of the community, and you need to make it voluntary. But when people find out in their classroom or in their workplace they've detected COVID or another virus, they stay home for a couple of days. I guess I'm curious. I guess I'm thinking about kind of the balance of the science of this and how we have to adapt. What we would love to do ideally isn't going to work in most places, and so how we roll in the individual locations' concerns about either the stigma or what they'll actually do, that sort of thing. And that kind of rolls into the bigger question that we've been thinking about over the last number of days, and that is, the attack on science and the misinformation and the disinformation that goes out there. I don't have any answers. I'm not even sure I'm formulating a question, but it's sort of what I'm thinking about in terms of how this all fits into a bigger picture.
Astis or Sunil, do you want to answer that?
Yeah, I can respond to it because I agree with Naomi. Maybe if we had started in the 1950s, when I go back, and I am actually a student of tuberculosis now, and I read what has happened since 1950s. As I said, our chances of being able to eliminate the disease was higher in the 1960s, even prior to 1960s, 1950s. So the hospital that I work in, the medical school that I work in, was established as a sanatorium, TB sanatorium, in the 1950s, and it housed patients, a large number of patients at that point in time. But it was not something which was out of bounds for general people. People would think of it, see it as in existence, but won't despise it, abhor it, or feel bad about it. What we have done over a period of time, this is my understanding, and I wrote a paper on this also. What we have done over a period of time, we have made tuberculosis program very loud, and it's in everybody's face now. So it's like chasing the disease now. So the way we did cope with COVID. So the emphasis now is go and get him. So the problem is that you will go to a village and identify a tuberculosis patient, get him, treat him, find his relatives, get them, start a TB preventive therapy with them, So you're actually chasing them. You are not letting them come to the system. And that chasing them is taking them away from us. I think that's a simple human behavioral aspect. If you chase them, they will run away from them. At some point in time, this is something that I've advised to the government as well. We need to be pretty relaxed as far as TB control is concerned in India. We need to be a bit relaxed about it. We don't need to be very hard pressed on it. We need to do it. We need to have the numbers down. So that's where probably the problem is as far as TB is concerned. I share a story with every time I talk about TB in India. I share a story which my respiratory medicine specialist told me. He said that one day he was having a patient with chest complaint coming to his office, and he investigated him, put him two tests. I'm narrowing down the tests. Gave him two tests. One was for tuberculosis, and second was for malignancy. So he was investigating him, keeping it as a differential diagnosis. Eventually, in India, we keep this as a differential diagnosis whenever we find pleural effusion, for example. So when the patient came, he told him, "There's a sad story." The physician told him, "There's a sad story that I have that I have to share with you. You are having bronchogenic CA." The old man sat in his chair and said, "Thank God I don't have tuberculosis." So he was pretty much happy to have bronchogenic CA than tuberculosis, which is much more treatable, has a higher chance of recovery than a bronchogenic CA. So the fact is that you start chasing them, you start bothering them too much, is something that drives them away. This is my understanding as far as TB in India is concerned.
Is this anything you want to add? No.
No, other than emphasizing that I think anything that requires any kind of forced actions is unsustainable. It has very, very short-term effects. So if we want to work on like sustainable solutions, as Nam mentioned, has to be either like non-invasive or voluntary, and but then that requires scale to root things out.
Yeah. Ilan, you have a question?
Yeah, I have a comment, or two comments. One is from the perspective of a person whose dad died of tuberculosis at age 41. Okay, so we don't very often hear about or from people who are impacted. Okay, we hear, it's taking the perspective of officials and scientists. You get a little bit detached, and I think it's useful. I don't hear people saying, "Hey, we're telling people here's the life story of individuals and their families who are deeply impacted by somebody who's lived with tuberculosis, maybe for a decade or longer, and then died." And this is what not treating it really means. Okay. So that's one perspective. It is not a good thing. And somehow that needs to be communicated in a vivid way. The other thing that I'm curious is that from my physics background, I got involved a little bit with a COVID response business. And I said, where is the actual broad thinking? I mean, these respiratory issues and pandemics are merit, and perhaps they've had like a Manhattan Project response, but not the same results. If you will, the CRISPR and the mRNA, they're great. But I'm not hearing somebody saying, "Hey, we have all this fantastic remote sensing capability that I can tell you what molecules I can find, a million light years from Earth, and why can't I identify those molecules with remote sensing, a meter from me?" Okay. Why do I need to have a wet chemistry test to identify COVID or TB? If there are molecules in the air, I should be able to do a femtosecond laser pulse that doesn't hurt anybody, that could identify rather precisely,
Yeah.
what's in the air and what's the source of it. Okay. And all of that. So I'm just raising this. I'm not going to solve the problem here, but
Let-
I'm not here. I hear a gap, a huge gap in the technologies that are being applied. So that's all the comment I'll mention over here.
Astis, you want to pick that up, or Sunil? I have a comment that I will just articulate because
You start, then I will respond to it.
we've seen this as being a structural issue, that using new technologies and developing new technologies has been very much underemphasized in the context of outbreak response. And this is, by the way, we're talking about, Sunil was talking about using a $15 fan funnel and filter to be able to detect diseases. But there were technologies that were developed. They're available in principle, though the companies have not been able to get implementation. To have a device that could, within 1 minute or 2 minutes, detect it using a standard particle counter, using technologies that are available. It's not cheap. It's $50,000 a device when they developed it, but it could sit in an airport and detect everyone walking through and if they're breathing out particles. This is not a problem for technology development now. It's a problem for societal priorities to make sure that these get adopted because they can solve these problems. Sunil, you have something to add.
I totally agree with Ilan's discussion on it. And maybe 6 months back, I was also thinking about on the same lines. I thought we have actually not worked a lot on the physics of tuberculosis, how exactly the physics applies to tuberculosis, because I see it more physical than biological. But I'm not a very good physicist. I am very poor as far as physics is concerned. And I interpret physics in this sense that I spoke to, again, my health authorities, and I told them, look, if you are looking at a high altitude place, say, for example, in my own places, there are certain high altitude places. There are 14,000 feet height places in India, in my state. And I asked those who man tuberculosis centers there, I tell them, how many patients of pulmonary tuberculosis do you see? My understanding of physics tells me that they should not be seeing any pulmonary tuberculosis. So most of the patients that they should be seeing should be extrapulmonary, because in tuberculosis, they will need the air, and the air is rarer there. The chances of that air being able to take care of tuberculosis, get it into the system, and being able to fuel continuously enough air so that it survives in the system is very low. So can we replicate such things in lower down in the other parts of the country, wherein we are able to take that technology to individuals, create such situations wherein the bacteria doesn't thrive at all in the human system? So this is something that has been in my mind. But as I said, I'm not very good at physics. And I agree with you. People from physics need to start intervening more on tuberculosis than biologists, because biologists are making a mockery of tuberculosis. They're killing it.
Joa, you have a question. Or comment. Where's Joa?
Yes, thank you. I have a comment and a simple question. First and foremost, I would like to appreciate the topics, and more so what Matthias and Aistaitis Simaitis brought. What about the non-invasive environment testing? I would like to say that here in Uganda, during COVID, schools were closed with a lot of pains. And as they closed the schools, it disturbed the sequence, the terms and the exams. Even a whole year, some pupils and students lost. Now, this one of surface testing trials, which was done in Lithuania, in hospitals, daycare, and public government institutions, I think was a very good thing. And more so, what I have liked is the one in the daycare and schools. The reason I say this is that what was done was non-invasive, and it led to schools, to the daycare actually not being closed. So that was a good thing that was done. Now, among the tests that are done, I've noted wastewater monitoring, wastewater monitoring. And my question is, in this wastewater monitoring, is sewage also monitored? And if sewage could be monitored in the same way as this wastewater we are monitoring, it would help in places which are prone to have cholera, whether they could also monitor the E. coli at the same time, and therefore give some adverse warning to the possibility of getting cholera in that community. That's my question is about that wastewater monitoring, if it can involve also sewage water monitoring. Thank you.
So we don't have Matthias in the room who does the sewage monitoring. So I think you will have to ask him about the details of what is available there. But
Yeah.
I'm sure that we can get his answer to your question.
The answer should be yes. Yeah.
Go ahead, Estes. You can answer it. Go ahead, say.
No. The answer is yes. Like wastewater and sewage, everything is monitored together. Actually, at least in Lithuania, they just do the same mixing, and it is actually done regularly for like drug testing as well. For like the institutions monitor of what type of drugs are people using and things like that. So there shouldn't be any problem to combine the two.
Yeah. Sunil, I think we should bring the session to a close. It's actually good that Joa spoke because I have a special extra piece here that I want to insert. Just to mention it, Francois from Congo is here, and he wasn't able to join on Monday. So we're going to cycle back to the Monday program on Ebola and have him speak for a few minutes, if that's okay with you, Sunil.
Perfect.
Great.
Do you want to say a couple of words before we close? Or are we all set?
All set. I think we have spoken a lot.
So let me just say that I really think that this TV project is very exciting. I really thank Estes for joining us to explain about this surface testing and the testing strategies that he has developed. I think it's super important. And Matthias did have to go, so we will have to thank him directly at some other time, but I think we all appreciate that he was able to come and tell us about his work. Now, as I said, having said that, we have a few minutes during the workshop time I would like to devote to cycling back to the Ebola outbreak. We had wanted to have Francois speak about the situation in the Congo at that time, and he wasn't able because of technical difficulties. Fortunately, he's able to join us now and to tell us about a little bit more about what is important about the outbreak there. Francois, please go ahead. Francois is based in the community in Congo. Go ahead. Go ahead, Francois. He is here. We can't hear you,
He
Francois.
looks frozen. Is he frozen?
Maybe frozen. Is he mute? He's unmuted, right?
He's unmuted, but he's not, he's frozen unless he's really breathing very shallowly and not moving.
Let me just check with him because
You may need to just reboot.
unfortunately, the connections for a Zoom call is somewhat limited. He doesn't really have to have, he is left and is rejoining. Let's give him a minute to do that. The plan is, of course, that we will switch to the teen time. And just to emphasize, today is also appreciate the program and the opportunities for the workshops. But today is not the closure of the efforts. Today is the beginning of our ongoing activities after this meeting. And I'm looking forward to continuing these efforts. Let me just check if Francois is.
I don't see him. I wanted to ask, Ynir, are you going to talk about cross-team capabilities as well?
Yes. So one of the teams that we have, Francois somehow. So then what we're going to do is we're going to break out into breakout rooms. We will continue with the following projects. Can someone remind me, because I don't have it in front of me right now? If people would like to talk about environmental testing, Sunil will be present in a breakout room. Do we have the list of the breakout rooms here?
Yeah, the others are implementation science, cross-team capabilities. We are going to continue with problem of disinformation. The alternate pandemic plan also is going to have a breakout room today, and cyclosporiasis.
And there's been a breakthrough apparently in cyclosporiasis that we just heard about, that apparently a particular source, a particular distributor of lettuce has been identified, and Holly may be able to talk about that. We do have Francois back now. Francois, can you unmute? So I will again go through it when we are finished. Let's see if Francois can speak. Francois? You have to unmute, yes. There, go ahead.
Okay. Good morning, everybody. I'm Francois from DRC. Can you hear something from me?
We can.
Can you hear something from me?
Yes. Yes.
Yes.
Okay. I'm so happy to share in this workshop. I've enjoyed topics for yesterday program, and I have to excuse myself for some days of my absence in the workshop because of technical problem. So I'd like to say something as a following about against some actions
from science development or new technology. I'm glad to know that one of goals of the workshop is to defend and to protect science and people. So my few contribution is taken from the Africa.
All right. We may not get his contribution. What we may do is record it and then share it. Obviously, the main things that we've learned from them have to do with the community-based efforts, importance of communication and disinformation and so on. But we will have his words and make a recording and then provide it as part of the shared efforts.